Hello everyone, today we are going to start with assembly again. So this is the second lecture for assembly and we are going to make flange coupling assembly today. And we are going to cover some more features related to assembly. So we'll start with the part. I'm having the flange coupling assembly parts here. You can see here, this is the exploded view of the flange coupling assembly. So there are total three parts, that is this flange, bolt and this nut. So we'll start with the flange first. So to make this flange we are going to use revolve command. Shift to solid edge, select the feature, select the required plane and start with this sketch. So we are going to make this sketch for the flange so as to make it revolve. I'm going to make this line vertical here, put up the required values. So here the diameter is 220, the upper diameter, and the second diameter is 124. So for 220, I'll take the distance from the axis as 110. As we are going to revolve the part, that's why we are taking radius as the value. Next, this is 124. So I'm going to take 62 here for this diameter. The last one is of 100 diameter. So we'll take 50 mm here. Next, the thickness is given 25. We'll consider this thickness as 25 only. So this length was 125. First one we have given 25. Second one is 125. Next we'll provide one relation here. I'll say this as vertical. And you can see this complete sketch is fully defined here. Fully constrained. As it is showing in black color, we can directly go for revolve now. We just need to make one axis here. So I'll draw one line and say this line as axis of revolution. It is compulsory for us. If you directly go for the feature and then go for revolve, it is compulsory that you should select this axis of revolution and say this axis as axis of revolution. Say close sketch and this complete flange is being made. Say finish and cancel. Next we are going to go for this holes here. They have been made on the PCD circle of 192. So I'll make one sketch on this face. We are going to draw one circle here. Take this value as 192. I'll say this circle as construction as it is a PCD circle. Then we are going to go for one cutout. So here the diameter is given 20. I'll make this circle here at the bottom side. We need this diameter to be taken as 20. Next we are going to cut the circle here. Say close sketch. Say extrude. Select the circle. Say OK. Now we are going to cut this part. Finish and cancel. Next we are going to go for patterns. Select pattern. Select the required feature to be pattern. Say OK. Next select the face. We are in sketcher mode. Select the type of pattern required. I'll say circular here. Next we need to select the center of the part and center of the feature. Here put up the input values. So count I required here is, there are total 6 holes given here. So I'm going to say it as 6 count and then click and say close sketch. Now we need to remember the first hole. So this was the first hole we have taken. Say finish. Next we are going to apply one appearance also here. I'll take it as steel head hot. Say close. Next we are going to go for one bolt. Say part and say OK. So the bolt dimensions are given here. 105 is the overall length. 15 is the length of the head. And hexagon is of 35 in between sides. So we are going to go for the commands now. Select the planes option. Go for the right plane. Say extrude. I'm going to make one hexagon. The diameter will be 35 here. Say close, sketch and extrude. So the extrusion was of 15 mm. Say finish and cancel. Next, we are going to go for the shaft. For that, I am going to make revolve. We can also go for the extrude boss here, but I'll prefer revolve first. So revolve, select the plane, and I'll make one half sketch by 2-point rectangle. So here the dimension for the shaft is given 20. I'll take it 10 mm. And this dimension is given 105. Say close sketch. It will ask you for making the revolve axis. As I have told you earlier, it is compulsory for us to make revolve axis. So I'll select this command here and say this line as an axis of revolution. Say close sketch then. And you can see this complete axis or shaft has been made. Next we are going to go for the fillets here on the head side. We can see here this fillets. There is no specific value been given, but we can see here it is not fillet, actually it's chamfer here. So we can either go for fillets or chamfer, anyone. For that we need to select a plane which is crossing the maximum distance of the cross section. So the maximum distance of the cross section for bolt is between these two corner points, and here we can see front plane is passing between two corner points. We can either go for these points also here or these points also, but I am selecting these points as the plane is already been present there. So select the sketch, select the plane to be sketched, and we'll make one profile for the revolve cut. I'm going to go for triangle here at the corner side. It is compulsory for making this sketch on the corner only at this cross section. Dimension we are going to give here is 2.2 on both the sides. Now we need one axis also here, so as to revolve cut. So I'll take this line here and we'll consider it as axis of revolution again. So I'm going to make it construction. This time I have not selected this axis of revolution. It is because we have not gone directly by feature. We have drawn the sketch first and then we are going to go for feature. So in this condition we don't need this axis of revolution here. We can just go for construction line also here. Say close sketch. Now we are going to select the command. Select add or cut. I'll say cut here. Select the profile step from the sketch. Say OK. Next going to go for the axis. So I'm going to select this line as an axis. So we can see here this bolt has been cut by the chamfer here. Say finish and cancel. So I'll hide this base reference planes and base also, sketch also. This bolt chamfers are being made on the upper side. Suppose I want to increase the size of this sketch. So I'll say edit sketch again. I'll say 2.8 by 2.8. And you can see here the size has been updated. I want to hide this sketch again. At the lower side, sometimes chamfer is also given. We have not made chamfer this time here. Next, we are going to go for the appearance. So for appearance, select View tab, say Part Painter, select the type as body here. Then we are going to say tan, and this bolt is also been made here. You can see it. So now this bolt part is also been completed. Next, we are going to go for this nut. So for nut, this width is given 34.6 and the internal diameter is given 20 mm. Total width is also given 20 here. I'll say new part and OK. This time also I'll select right plane, say sketch, again hexagon here. This width is given 34.6. So after exiting this sketch, we are going to go for extrude boss. Say the selection as select for sketch. Say OK and say extrude. So the extrusion here is given as 20 mm. Say finish and cancel. Next we are going to select the plane which is crossing the maximum distance of the cross section. For making the chamfers here, Again, I'll take this size as 2.8 by 2.8. Say both the sides equal. Next, we are going to draw one more profile on the other side, or else we'll go for mirror later. So I'll continue with this one profile only. Just make one line for the axis. Say this line as construction. Say close sketch. Next, we are going to go for revolve cut. Select the feature. Select the sketch. Say OK and then say the required axis of revolution. I'll say to cut the material, it is added the material here. I'll say cut, and we are going to go for this option, that is revolve 360. So finish and cancel. So after this cut has been made, I'll hide the sketch and mirror the feature on the other side also. As we can see here, this nut is having chamfers on both the sides. So we need one plane there. For that, select the plane option, go for parallel plane, select the reference plane or face, and then go for the distance. So the total width was given 20. The half distance will be 10 mm here. This plane we have taken here is just for making the mirror command. So here mirror, it is asking you to select the features required or included. Say OK. Next, select the plane required, and then we can say finish. Here it is. We can see here on both the sides these chamfers are been made. Next, we are going to go for the cut here, that is of diameter 20 mm. So for that also we are going to make one sketch on the upper face. Circle with diameter 20. Say close sketch. Say finish and cancel. Select this extrude, select the sketch, say OK. Say finish and cancel. So now this cut is also been made here. We'll go for the appearance option. I'll hide this sketch here. So for appearance, I can view part painter. Select the color here as, I'll say purple, and say close. So now this color is also been applied here. We'll save all the parts now and then go for the assembly. So we'll go for the assembly here. I'll select isometric assembly. Here we need to call the parts, so I'll say insert components. Browse for the folder. I have saved this part on the desktop. I'll select the required folder here. First I'll call the flange part. So in earlier lecture also we have seen the first part we have called will always be grounded. Grounded part or grounded made means the part will be completely fixed. So if you want to make it fixed and continue, you can go for directly calling the other parts, or else you can remove the ground made, go for the planes made, and then we are going to match all the center planes of part with the center planes of the assembly. That method is more preferable here. So I'll select this part. We can see here this part is showing that it is having a ground mate on the left side in model tree at the lower side. So I'll select this relation and say delete relationship here, and we'll drag this part so as to move it from one place to another. I'll keep it somewhere here. Next we are going to make this planes on. Also going to go for the part planes, say right click on the part, say show hide components and select the reference planes as on, say apply and OK. So after making the planes visible, we are going to go for the mate. Earlier we have seen only 3 mates in the last assembly of press tool, that were axis align or axial align for matching the centers or making the parts concentric. Next was mate, making any two faces coincide. The last one was planar align, making two planes coincide. So this time we are going to select this command as assembly. So while you select this assembly command, we are directly assigned to this feature, that is flash fit. So flash fit means the definition is being shown or highlighted there, you can see. It applies the most appropriate relationship from the mates. Means according to the selections, it will by default take the most appropriate mate required there. This command assembly and this feature are same. As soon as I click on assembly, flash fit has been activated there. This is flash fit. So these are one and the same only. So I'll select assembly. First we'll select the plane of the part and then go for the plane of the assembly. Next, again right to right plane. So while selecting assembly, it will by default take the required mate according to the selections. You can see here. We don't need to select different types of these mates which we have seen earlier in press tool, all the three mates. This axial align is also included in assembly. The mate with faces, that is making faces coincide, and the mate with planes, that is making planes with coincide, is also included in assembly only. Next, we can also go for this connect command by using this assembly tab directly. So we don't need to select the features separately here if you are using this tab, that is assembly, nothing but flash fit only. So after aligning all the planes of the assembly with part, we are going to call the next part here. That will be copy of this part only. Say right click, again we'll go for the command that is coincide. So select both the faces to make coincide. We can say flip orientation here, and the orientation has been flipped. Next we are going to go for the axis match. So it is very fast and easy to work with this assembly tab. It is very convenient to work with. Lastly, we are going to match the holes. And the flanges are being made here. Next we are going to call the part here as bolt. So I am going to insert the bolt here. Select the axis and this axis. And I'll say lock rotation also here. And say flip direction. Then go for this face to face, and we can see here the bolt is been placed. Rotation is also been locked. Next we'll call the bolt here. We need to make sure this bolt is being mated with the first hole of the flange, which was made before pattern. So make this bolt concentric with the first hole only according to the feature. So I'll say assembly again. Select the axis with this axis. Say flip. If you want to lock the rotation, you can lock it here, or else you can do it later also. I am not locking the position here. Next, I am going to say face to face match, coinciding the faces here. Next, say right click and finish. So you can see this bolt, this blue color sign is coming along the symbol. So this blue colored signs on the opposite corners showing is that under constraint material, means this part is under constraint. So we need to make it constant by locking the rotation here. Select the part which we need to lock the rotation, and you can see the related mate is shown here at the left side in model tree. Select the mate and say lock rotation, and you can see this bolt rotation is now locked. It is completely constant. That's why this blue colored sign is also been removed from the icon. Next we need to go for pattern here. So for pattern, select the pattern tab. It will ask you select the part to be included in pattern. Say OK. Then it will ask the part which contains the pattern. So I'll select this part. Then it will ask the holes that contains the pattern. And this will ask you for the base hole next. So this will be the base hole. You can see all the bolts are been patterned here. Say finish. I'll repeat it once more time. Select the item to be included in pattern, say OK. Next, go for the part which contains the pattern. Next, we are going to select the pattern holes and the base hole. Lastly, we are going to select the base hole. Say finish and OK. So the pattern has been completed here. Now I'll undo all the parts here. Means I'll remove the bolt also here. I'll select this part and say delete. And we will again call the bolt part here, because I need to show one more mate, that is this insert mate. It is usually used most of the time for bolts only. So I'll select this mate here, select the axis, select the whole axis, select the face required to be coincided on both the parts, and here the mate is completed. Means we don't need to give 3 mates, or we don't need to give 2 mates and then go for the lock rotation. It will fully constrain the part in one command only, that is insert command. So you can see this part is completely constrained. We'll repeat this mate, that is insert. Again delete the bolt. We'll call the bolt here. Next, go for the feature insert. Select both the axes. Select both the faces to be coincided. We can see the insert feature has been applied. We are going to see one more command here. It is similar to pattern only. Now one more next command or feature we are going to see here is that clone component. It is similar to pattern only. Select the clone component, select the part, say OK. Again we need to select the feature in which the part contains, say OK again, and then select the part. You can see as I have selected on the flange face, these bolts are again being made pattern here. Say OK again and finish the command. We'll repeat it for the nut also here. Just say assembly axis with the bolt axis, then face with the flange face, right click and finish. Next we are going to log the rotation of this nut. You can see it is showing in the mid that rotation is unlocked at the left side. Say log rotation. Then go for this option again, repeating that command, that is clone component. Select the part, say OK. Select the part on which this part is mounted. Again say OK. And then we need to select the similar occurrence parts. So nut will be assembled on all the similar parts or bolts. Say OK. Say finish and cancel. So in this way the assembly has been completed here. You can see here flange coupling assembly. There is not a single part which is under constraint, and you can see here wherever we have used the clone component in model tree, it is showing assembly group. So if you expand this arrow, you can see all the bolts that are being contained in the assembly group by making clone components. So we have seen here assembly feature. This assembly feature contains total 4 mates, that is axial align, face to face mate, plane to plane mate, and point to point connect mate. Assembly feature and this flash fit are nothing but the same only. So if I select this flash fit also, it will give the effect of this feature only, that is assembly. Next we have seen the other commands as pattern and clone component. Now I want to see this assembly in a section view. We need a section view in assembly. So for that again we are going to go for PMI option, and in section I'll select this option, that is section. We need to select the coincide plane here. So I'll show the planes here. I'll select this mid plane. Next we need to draw a sketch. So I'll say 2-point rectangle. I'll draw a rectangle here. I'll make it constrained according to the cut I required here. Say close sketch. And now it will ask you to cut the material, on which side we need to cut the material. So I'll always select the inner side of the sketch being made, and then it will ask you the direction of the cut. So I'll take it on the front side, say OK and finish. So you can see here I want to hide the features, so I'll hide the planes here. Just go and say right click and show hide all components. I'll say hide all the planes, apply and OK. Again we'll take the section plane. I'll hide this section here in model tree. Again go for the section. This time I'll select the plane by keyboard only. So just need to click on XYZ on the keyboard so as to take the references of XYZ planes. So you can see here I have taken reference of the Y plane here, and the section view is shown. Half section view of the flange coupling profile. Say finish. So this was flange coupling assembly.